Hi, this is Maggie. In this video we're going to talk about concrete versus abstract base classes. In the last video we were looking at a publication program with an inheritance hierarchy consisting of a content item class and an add class. What we were envisioning is an inheritance hierarchy with content item as the base class or superclass, and at least 3 derived classes or subclasses, article, add, and image, but then also possibly future classes such as quiz, survey, or interactive statistics. I'm sure you can imagine others from the content you've seen on the internet. In both implementations, the text-only minipub and the graphical publication, content item was a concrete base class. This means that the user of this class can create an instance of it. We're looking at the graphical version, and you can see that in main, we create an instance of the content item class. I really didn't intend for content item to be a concrete base class, though. I was just trying to keep the code simple. Ideally, I'd like content item to be an abstract superclass, which means that it would not be instantiated. In other words, we'd never make a content item object. Conceptually, it doesn't really make sense. What is a content item exactly? From the perspective of the page object, it's something that can be laid out in the window and that can respond to a click. But from a content creator perspective, it's a generic label for more specific kinds of content. I was really creating an article when I created a content item, although I created it as an image. If we're designing the system with content item as an abstract base class, we draw content item in italics in our class diagram. Any user of our inheritance hierarchy should not be creating an instance or object of the abstract class. If a class is an abstract superclass, it might leave operations unimplemented. In other words, there might be empty methods. These should be overridden in the subclasses. So the abstract superclass has basically placeholders for behavior that will be specific to each concrete subclass. This provides a public interface to any part of the system using the abstract superclass. So, for example, we don't implement handle click right now in our content item class. We have the code pass. But if it was necessary to provide some behavior, we would have to fill in that method for each subclass. Having the method in the superclass allows the page class to send the handle click message to content item subclass objects. Now, let me subclass this with an article class, and instead of creating a content item object in the main function, we'll create an article object. Now, here's how an article really should be distinct. It should be composed of text. So what I do is initialize it with a text parameter, and then convert that to an image and call the superclass constructor with that image. To do this, I use a few pygame commands that will convert text to a surface. And this is still really quick and dirty. I just wanted to distinguish article from add in a way that I originally intended. The abstract superclass content item contains the image, which is basically whatever the content is rendered as an image, and the XY coordinates of the image. And it can return whether there was a click within it, and it can draw its image. And add, as you know, will actually respond to a click by doing something, and an article will render its text as an image for drawing. Ideally, we would be able to resize these different objects, and then of course the text would resize in a completely different way from a graphical image. We'd want to render it again in the new size. The graphical image would have to be scaled while retaining its aspect ratio. So there's quite different functionality. It's not just functionality I want to get into implementing here because it's a lot of detail that is unrelated to the idea of an abstract versus a concrete superclass. In this program, we never create an instance of content item. We only create instances of the 2 subclasses, but many of the messages and some of the data still are the responsibility of the abstract superclass methods. Whether you create an abstract or a concrete superclass, there's no difference in the syntax of subclassing or calling superclass methods or overriding methods. The syntax is the same. Abstract versus concrete is a design distinction, and it's important that users of the hierarchy are aware that they should not create instances of an abstract superclass because the methods might not be implemented. It is not intended to be an object in a system. You will choose to make an abstract superclass if you want to have a public interface for a collection of related classes, but that public interface itself doesn't make sense as an object. You'll use a concrete superclass if you're specializing a class that is already being used to create instances, for example, if that class is part of a library that you're using. Or you'll use a concrete superclass if it makes sense for the problem that you're solving. With practice, you'll learn when each is the better choice.